Hi, we're Fine Frontier Aerospace at Kansas State University. My name is Ben Murdoch. I'm a junior in mechanical engineering, and I'm the president of FFAERO. This year, we're bringing our project Space Wagon to the Spaceport America Cup. Space Wagon is a 6.6-inch diameter rocket standing over 11 feet tall. It's flying on an Aerotech M1939, and its stability margin at liftoff is 2.51.
Hi, I'm Zach Dyrett, the SAC competition lead, and I'm a junior in electrical engineering. This year, we decided to design a rocket in modules, which will allow for more reuse in future years of components. Every module has a coupler on the aft side and room for a coupler on the forward side. All the dimensions of these couplers are the same on all of the modules, which allows them to be assembled in any order. This year's rocket has 6 modules: the booster module, 2 Baffles modules, the electronics bay module, the payload module, and the nose cone module. Designs like this are easy enough to model in SolidWorks using assemblies. However, in OpenRocket we have more problems since it doesn't have the concept of an assembly. To solve this problem, we developed this new piece of software which allows us to assemble together different part files into a single assembly. This is nice because it allows us to form different configurations of our rocket using common subcomponents, and also allows us to rebuild the entire assembly whenever one of the subcomponents changes without having to manually update all of the different assembly files. This software is also available for download from our GitHub page here.
Hi, my name is Brett Funk. I'm a sophomore in mechanical engineering and the vice president of FFAERO. To create the fins, centering rings, and bulkheads for the rocket, we used a custom fiberglass vacuum infusion method that the team developed. We began by taking a sheet of acrylic and applying a silicone lubricant spray to it. Next, we cut 12 identically sized fiberglass cloth sheets, about 2 inches smaller in either dimension than the acrylic sheet. After that, we took 1 sheet each of peel ply and infusion mesh, the same size as the fiberglass sheets, and laid them on top. We then ran a strip of vacuum tape all the way around the acrylic sheet on the border. Finally, we applied a vacuum bag over the top of the whole assembly and attached 1 tube on either end of the assembly. We then pulled a vacuum over the whole thing and allowed epoxy to run into one of the tubes. The vacuum pulled it through the assembly into the second tube, where excess was caught in a bin. After the sheet had been fully wetted, we allowed it to cure. When the sheet was cured, we used a Dremel to hand cut the fins, centering rings, and bulkheads out of the sheet.
Hi, I'm Keegan Taylor. I'm a senior in mechanical engineering, and I'll be talking about the body tubes. The rocket consists of 5 sections of body tubes: the booster section, lower baffles, electronics bay, upper baffle, and payload. The team custom made the body tubes out of fiberglass. For the mandrel, we used a 6.625-inch PVC pipe, and we prepared it with car wax, silicone spray, and wax paper to help with its removal after the fiberglass cured. For the wrapping, we applied epoxy to the mandrel and laid the sheet of fiberglass around it. And as we wrapped the fiberglass, we applied epoxy to each layer of fiberglass until we had 6 layers. Then after the wrapping, we applied a sheet of peel ply to the outside to help improve the surface finish of the fiberglass. Then after the fiberglass cured, we used ropes to help separate the mandrel from the body tubes. And then the body tubes were sanded by hand and cut to length. The couplers were made in a similar way. Some of the differences are that we used a 3D printed part as a mandrel, and to separate the parts we put them in the freezer, and that allowed them to easily be separated.
Hello, my name is Grant Nickel, and I'm a junior in the computer engineering program. This year for the nose cone, we used a 2-to-1 tangent ogive shape. We use this because it's one we're more familiar with and one that is easier to manufacture in the design. And so for the manufacturing this year, we made it ourselves, and instead of previous years where we used one large sheet of fiberglass to cover the interior mold, we instead used a lot of smaller strips of fiberglass to kind of wrap the mold with various lengths of fiberglass and try to make the position of the fiberglass strips so that it doesn't build up in any one spot. This way we were able to have a much smoother outer surface prior to sanding, which made the job of sanding quite a bit easier and made sure we didn't have any horrible ripples or anything on the outer surface. So then once we got the fiberglass wrapped to about 4 layers thick, we placed epoxy over the overall cone, and then placed the cone inside of the exterior shell that we 3D printed. We 3D printed these shells because it makes it easier to peel off once the epoxy is fully cured. So we peeled off the plastic from the inside and outside of these shells to expose the overall nose cone. And then once we got the nose cone exposed, we were able to sand it and try to get a smooth outer surface to make it better to fly.
Our electronics bay consists of 2 fully redundant systems. We have the Altus Metrum Telemetrum and the Altus Metrum Easy Mini. Both of these have a completely separate battery for their power and key switches to power them on and off. Additionally, they have 2 separate screw terminals for the charge on both sides of the bulkhead so that we have a primary and a backup black powder charge. All of the electronics are assembled onto this aft bulkhead so that it can be removed from the rocket, and all the wiring is fixed on that one assembly so that we can take it out of the rocket to work on wiring without having to have long wires that are required if you have electronics on both bulkheads.
This year, to protect the parachutes, the team opted to design a Baffle system. Inspiration was taken from Apogee Components' newsletter, where they described a few different types of baffles. We decided on a hybrid design, operating with a plugged-in model and a Type B baffle. The plugged-in model has a vent hole before the end of a tube. That vent hole before the end of the tube allows all the burning embers and particulates to get caught past the vent hole in an effort to help protect them from escaping the baffle. The Type B system had multiple interconnected tubes, so the air has to snake through the baffle system before it's exposed to the parachute. On the left here, you can see an exploded view of the baffle system. Once the baffles were assembled, a mock test was completed to confirm that they actually worked. As you can see here, this is an image from that test. You see flames from it, but our piece of ripstop nylon was attached to the top of the baffle system. That ripstop nylon was unharmed after the completion of this test. Even though there are flames, the baffle successfully contained all of the burning embers and particulates that would harm our parachutes.
Hi, my name is Miranda Dodson, a graduate student in electrical and computer engineering. Today I'll be discussing our CubeSat design for our payload section. Our payload is composed of 10 centimeter by 10 centimeter by 10 centimeter blocks called CubeSats that are able to hold our various payloads in any configuration that we'd like. Here we've created a payload board section that can have removable sidewalls, and these are good in case we want to replace those sidewalls with PCBs. This will allow us to have more actual payload space.
Hi, my name is Brandon Cooper, and I'm a junior in mechanical engineering. Here we have the radio electronics board that we can store inside of our payload carrier, as well as our variable weight payload. The payload is used to vary the overall weight of the rocket, or we want to get to our 8.8 pounds. Inside of this payload, we'll have metal plates weighing 283 grams. That will make up the majority of the weight in the 2 to 3 kilogram range. And then for more minimal weight changes, we'll be using 0.29 gram washers to just get that fine-tuned mass.
Hi, my name is Lindsay Kroll. I am a freshman in mechanical engineering, and we are looking forward to launching Space Wagon on October 16th in Argonia, Kansas. Thanks for watching.